Hello all, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to study about a very important topic of class 11 NCERT, that is equations of motion. So we will study the equations of motion. Here we will study 4 equations of motion regarding the equations of movement in a straight line. So without wasting time, let's dive in straight to the class. So equations of motion. So we have studied three main equations of motion in class 9. That is, first one is first equation of motion, that is v is equal to u plus at, and second equation is s is equal to ut plus half at square, and third equation is v square is equal to u square plus 2as. We had seen all these three equations in class 9 standard, and if you want to get it more familiarized, you can just go to the class 9 equations of motion. I'll pin the video link somewhere here, and you can go through that video and come back once again. In this class, we'll study one more extra equation of motion, that is the fourth equation, that is s nth. In the nth second, what will be my displacement, or the body's displacement? So here we'll study a very important equation, and we'll derive that equation, and we'll come to know how this equation has come into play. And this equation goes like this, that is u plus a by 2 into 2n minus 1. This will be the equation. Here this n is the time, this nth second. So this is the time, don't think that it is something else. Okay, here v is the final velocity, u is the initial velocity, and t is the time period, a is the uniform acceleration, and all these equations are related to the uniform acceleration, and s is the displacement. All these are the credentials. So without wasting time, we will get into the first equation. So we will see how this equation is derived. So v is equal to u plus at. By definition, we know that a is equal to what? Acceleration. Acceleration is the rate of change in velocity. So change in velocity by delta t. This is a time period, and this is a change in velocity. Now, what happens here is that we will limit the time period to 0. Okay, then this equation will become was what? Limit delta t tends to 0, delta v by delta t. So it will just become what? dv by dt. So this is a very important equation, that is a is equal to dv by dt. From here, we will just do some certain calculations and get into the equation. So from this, we will rearrange, and we will get dv is equal to what? A d. And now we will just derive this equation using the integration process. So we will integrate both sides, LHS and RHS. So you know that by integration, in integration you can see integration of delta dx is equal to x. So by here we are not using any special limit there. So integration will become delta, or integration dv will become what? V, that is equal to a is uniform, but here one more term will come there, that is the integration constant. So that is equal to k. Now we want this equation is not the equation which we want this particular equation, right? So we will do certain substitution method. At time t is equal to 0, then this v will become what? V is equal to u means what? The initial velocity. So I am just substituting here, so that what will become? If t will become 0, then v will become what? U. Then this equation will change to what? U is equal to 0 plus k, that is u is equal to k. So you are getting a value k is equal to u here. Substitute these value here, then what will you get? Then you will get the equation that which we require, that is v is equal to at plus, instead of k I am just going to write what? U. So it is u. So there comes the equation, v is equal to u plus a t. Here is the equation, first equation there. Using the integration method, we are getting the first equation. We can also use one more method, same way. Just come back to this particular equation, that is delta dv is equal to integration a dt. Here at time t is equal to t0, or we can say that what? T is equal to 0 or 0. Then v is equal to what? U. And the other condition, what is the other condition? If t is equal to t, then v is equal to, final velocity is equal to v. Then substitute it here. So if I'm just giving the limitation, that is u to v, then this will become what? T0 to t, or here if I'm just taking t0 is equal to 0, then this will be the equation. Then what will happen there? Then v minus u is equal to a t minus t0, or here we are taking t0 is equal to 0. Then that will become what? V is equal to u plus a t. Here comes the same equation. So using integration method, it is very easy to identify, to get the correspondent equation. So here comes the first equation of motion, that is v is equal to u plus a t. Simple thing, simple thing. Just go through that this particular derivation and do it yourself, and then you will understand the equation more clearly. Now coming to the second equation of motion, that is s is equal to ut plus half at square. Here in this equation, we are just taking the basic equation, that is v is equal to dx by dt. So we know that velocity is the rate of change in displacement. So here v is equal to dx by dt. From there, I am just writing dx is equal to v dt. Okay, you can write that thing, right? Just rearrange and you will get the thing. And here I can also give one more substitution. Instead of this v, I am just going to write v is equal to u plus at. You know this equation, the first equation of motion. Substitute the value here and you will get u plus at into dt. So you must know why I am substituting this value here. Because in second equation, s is equal to ut plus half at square, there is no term for final velocity or v. We have to express that particular equation in terms of initial velocity. So instead of v, I am just writing v is equal to u plus. So here is the equation. So from there, you can also write dx is equal to u dt plus at dt. Okay, I'm just splitting the bracket and I'm just getting this equation. Again, integrate. If I'm just integrating this process, integrating both sides. So integration will be applied to every terms separated by plus and minus, right? So here, this is the term. So now what happens? Okay, you know the integration. This is equal to x is equal to u dt plus a. So u is taken outside and you will get an integration process. A is equal to ut plus a into integration of x dx is equal to x square by 2, or simply integration x raised to n dx is equal to, okay, this will become what? X raised to n plus 1 by n plus 1. So here what is the power there? 1 is the power there, right? X raised to 1. So x raised to 1 plus 1, that is 2, divided by 1 plus 1. Here also same thing, x raised to n. Here integration will become x raised to n plus 1 divided by n plus 1. Keep this particular terms or this particular equations in your mind. So it's throughout the class for both mathematics and physics, you require this particular formula. So from there you will get integration t dt is equal to t raised to 1 plus 1. In here the power is 1. So 1 plus 1, that is 2 divided by 2. So here comes the equation. X is equal to ut plus half at square plus 1, k is also there, right? So now again substitute. How will I get the value for this k? So I will get the value like this. If t is equal to 0, initial displacement. So I will just say x will become x0. If t is equal to 0, x will become x0. That means, for example, if an object is moving, there is a man here or a lady there. So if I'm just taking the first time t is equal to 0, if I'm just taking this as my origin, if I'm just taking the same as my origin, then there is no movement. So I will just say it is my x is equal to x0. After time t, you can say this man or lady reaches this particular point, and this point is x. So my displacement is equal to what? X minus x0. This is what the basic idea or logic, right? So now if t is equal to 0, then my x will become x0. So if I'm substituting the value here, then what happens there? X is equal to u into t is equal to 0. So 0 plus at square by 2, that is 0 plus k. And what is this x? At time t is equal to 0, x will become x0. So this will become x0. So now your k value is equal to what? X0. So substitute this k value to this particular equation and then you will get what? X is equal to ut plus at square by 2 plus x0. If I'm just taking x0 to my LHS, then the equation will become x minus x0 is equal to ut plus half at square, right? And this x minus x0 is what? It is nothing but the displacement carried out by the object. So s is equal to ut plus half at square. In 9th standard, you are coming across this s by using your average velocity and all. If you're not getting, once again I'm saying, go through the videos which is shared in this particular channel for class 9 NCERT, and then you will get the idea. So okay, so s is equal to ut plus half at square. So this, here comes the second equation of motion, s is equal to ut plus half at square. And now what is about to the third equation of motion, that is v square is equal to u square plus 2as. So how can I derive that equation of motion? V square is equal to u square plus 2as. So here also I'm just taking v is equal to dx by dt. This is the basic equation. Velocity is equal to rate of change in displacement. So here I'm just using a small rearrangement. Let us just observe carefully. Dx by dt into dv by dv. If I'm writing like this, is there any issue? dv by dv. So the value is 1. So there is no change. So you can write like this. So I'm just rearranging once again dx by, instead of writing this dv here, I'm just writing it here. So dv into dv by dt. Is there any issue? I hope that you got the point. What is this dv by dt? You know that that is equal to acceleration. So again, v is equal to a dx by dv. Just take this dv to the LHS, so you will get v dv is equal to a dx. You want to integrate both sides. So v dv, you know that integration x dx is equal to, or x raised to n, dx is equal to x raised to n plus 1 by n plus 1. So here the value of the power is 1. So you can say, instead of integration here will become what? V square by 2 is equal to a integration x, that is equal to x plus 1. K is also there, k value is also there. So now what happens to the k value? What is the k value there? If I'm saying that if my x is equal to x0, my v will become what? U. So I'm substituting the values there, then I'll get v square by 2 is equal to a x0 plus k, right? So instead, so okay, here it will become u square, right? Now what happens there? So k value is equal to u square by 2 minus a x0, right? Now substitute, if I'm saying this is equation 1 and if this is equation 2, substitute equation in 1, then you will get what? V square by 2 is equal to ax plus, instead of a you will write u square by 2 minus a x0, right? From there you will get the value like this. You are just taking the values here, so you will get v square by 2 minus u square by 2 is equal to a x minus x0. Are you getting? Yes. So simple mathematics, from there you will get v square minus u square by 2 is equal to as. Instead of this x minus x0, I am just writing s. From there you will get v square is equal to u square plus 2as. Here comes your third equation of motion, v square is equal to u square plus 2as. So this is simple thing. Don't think that you just get the value of this k, substitute the value and get the answer. As simple as that. There is no big deal in finding out this equations using the integration methods. Integration method is very simple. The only thing is that you need to be careful here. That is how you are just transforming the equations. So here, why did I did this particular transformation? Why? Because you know that you need to just get this a value, because in your equation you have a value there and you have s value there. In the previous case, there is no v value, so you have just transformed that value v is equal to u plus at. So simple logic should be used there and you will get the answers correctly. So here comes the third equation of motion, that is v square is equal to u square plus 2as. So all the three equations, the previous equations which we had studied, is again derived using the integration method, and just go through the values, go through the equations and get the answers. Do it yourself, close the video, pause the video and do it yourself and get it clear, or just the clarity should be there. Okay, now coming to the fourth equation, which is a new equation that you haven't studied yet, but in this class you will study it clearly. What is the displacement in the nth second? So just moving to the fourth equation of motion, Sn u plus a by 2 into 2n minus 1. This is the equation that which we require. So how will we get this particular equation? So first of all, the thing is that just imagine that there is an object here and this object is moving from one point to another. Just imagine that this object has moved to this particular point and it reached to this particular position, and this is a time interval n, that is this time interval is n. Okay, so you need to find out the displacement at the nth second. So what will be the displacement there? So your basic thing is that just imagine that this object is moving, and if at this particular point and this value, the time is n minus 1, that is this much time interval is n minus 1. So if I find out the Sn, this particular displacement, and if I find the displacement, this one, that is this displacement is Sn minus 1. If I subtract this Sn minus 1 from Sn, then I will get this displacement. This displacement is otherwise known as Sn, that is from the displacement from n minus 1 to n. So this is the Sn. So, and that equation carries or is equal to u plus a by 2 into 2n minus 1. Here n is the time. Just understand that. That is a time there. So how will I find? I will find out this by finding out Sn, and then I will find out Sn minus 1, and then Sn is equal to Sn minus 1. So we'll start the equation. I hope that you got the logic or physics behind this, how to find out this particular equation. So Sn is equal to, here n means the time. So you know S is equal to ut plus half at square, right? So here ut is what? N here. So un plus half at square. Instead of t, it is n, a n square. This is the first equation. And the second equation, that is Sn minus 1. N minus 1 means time is n minus 1. So u n minus 1 plus half a n minus 1 the whole square. This can be written as un minus u plus half a minus b the whole square is equal to a square plus 2 a square plus b square minus 2ab. So n square plus 1 minus 2 n into 1, that is 2n. So this is the equation. So again, if I'm just writing, clarifying or simplifying, then Sn minus 1 is equal to un minus u plus half a n square plus half a minus 2 by 2 an. 2 by 2, that is equal to 1. So minus an. This will be the equation, right? This is the equation, right? Okay, now this is equation 2. So 2, 1 minus 2. So what will I get? I'll get this one, right? Sn minus or Snth. Second is equal to Sn minus 1, that is equal to, here un minus un cancel out each other, half an square minus half an square cancel out each other, and the remaining is, so more clearly, more precisely, if I'm just writing out here, so Sn is equal to u plus a by 2 into 2n minus 1. So here comes the fourth equation, that is fourth equation goes like this: Snth is equal to u plus a by 2 into 2n minus 1. So I hope that you got the point, how to calculate, how to derive the fourth equation, that is Sn. nth. So that's it for today's class. So I hope that you got the points, and just once again I'm saying practice these derivations and it will be very easy within fraction of seconds. If the question is asked, you can derive that thing, and for the exams you will not fear, you will not face any type of difficulties. So now we'll come in the next class with new topics of class 11th. So just stay tuned, and we need your support like you are supporting right now by your like, share, subscription, comments and all. So till we meet again, goodbye and have a nice day.